Awesome.
It'll lock
Okay.
up for a moment, and then yeah, now it's rolling.
Awesome. Thank you. You are the best. That is great. Now I can close this. Let's see. Hold on. Okay. Okay. Sorry, y'all. I don't know what was wrong with the recording thing, but I needed to record this. Okay. So parent functions. If you transformations, you guys really should know this pretty well, but that's nice. Anyways, we'll get a little break from difficult stuff. Right here, it tells you what the function form is, and they've just put an F in because any function could be in this place. So they're just telling us whatever function it is. If there is an A value in front, that represents a vertical stretch or compression. It also represents a reflection, but I like to look at those two things as two separate things. It's a little bit easier to understand that way, I think. The number inside with X, that's a horizontal change. Anytime something happens inside with an X value, X is horizontal. So that means that has to be a horizontal change. You guys did not do, you might have mentioned horizontal stretches and compressions, but you didn't really do them because all of the parent functions that we're going to talk about today and that you talked about in Algebra 2, you couldn't tell the difference between a horizontal stretch and compression and a vertical stretch and compression. But we will, in pre-cal, encounter functions that you will be able to tell the difference. So we'll talk about those later, but not until second semester. So we're just dealing with horizontal shifts. Remember, X is a liar, so anything that it looks like in the inside with X, it's going to go backwards of what you think. So if it says minus, it's going right. And then there's plus D at the end. That's a shift up and down. So the first parent function that they're giving us is the absolute value parent function. You don't really talk about that one very much in Algebra 2 because you do it in Algebra 1. So, but you know what it looks like? It looks like this. That's the original function. It's a V. Anything that is different from the, which, by the way, also could be written as y equals the absolute value of x. Anything that is different is going to cause a transformation to the graph. Now look, we need to be able to do these without plugging them in your calculator because it's a total waste of time. You can do them much faster if you just visually look. If I look at my original y equals absolute value of x, and I look at my new transformed function, there are three differences. The first one is the 2 in the front. What does that 2 do to the graph?
It pulls
Stretches
it upwards.
Yeah, it pulls it upwards. It's a vertical stretch by 2. Which means every y value is 2 times bigger than it was. So 0, the y value at this point right here is still 0, right? 0 times 2 is still 0. But this y value was 1, and now it should be 2. And this y value was 2, and now it should be 4. Because you take all of your y values and multiply them by 2. We're not going to do it right this second because we've got other things we need to do. What about plus 5? What kind of transformation happens here?
That shifts the graph left by 5.
Left 5. And then what does the minus 3 do?
Shifts it down 3.
Down 3. All right, so I need to take my original graph. I'm going to shift it left 5. 1, 2, 3, 4, 5. Down 3. 1, 2, 3. And then, so now my vertex is left 5, down 3. And then from there, instead of going up 1 over 1, I'm going to go up 2 over 1. And up 2 left 1 to make my new V. So it should look like this. Looking at number 2. Again, I have 3 separate transformations. The negative in front, the minus 4, and the plus 1. What does the negative in front do?
Shifts it right 4.
No,
Oh,
the
in the
negative
very
front. It reflects it across which axis? Yep. Again, it's a vertical change because it's not in the house with x, so we're changing vertically, which means it flips it upside down, flips it over, or across the x-axis. And then the minus 4 is right 4, and the plus 1, up 1. So my vertex is going to go right 4, 1, 2, 3, 4, up 1. And this time my graph is upside down. So instead of going up 1 over 1, I go down 1 over 1. New parent function. This is the square root parent function. This is what it normally looks like. It's easiest to transform these if you know some significant data points on the original. And on the original square root function, your significant data points are your origin at 0, 0, a dot at 1, 1, and another dot at 4, 2. Those are your significant points. If we know those, then it makes it easier for us to transform this. So I have 3 changes again. What does the 3 in front do?
Stretches it by 3.
Stretches it by 3. When something is vertically stretched, it should get closer to the y-axis. So, and if you think it makes sense, because if I were to pull up on that dot right there, it's going to make the whole thing get closer to the y-axis. What about the plus 6 inside?
Left 6.
Left 6. And the minus 4?
Down
Down 4.
Good. All right, so my origin's going to go left 6. Down 4. Normally from that dot, I would go up 1, right 1, but now I'm vertically stretching by 3. So I'm going to go up 3, right 1. Then I could go back to my dot, and from there I would have gone up 2, right 4. Now I'm going up 6, right 4. Take a second and try number 4 on your own. Looks sort of like that. You have a reflection across the x-axis. Left 7, up 8. Is everybody good? These are just sketches, so don't worry if the graph is not great. As long as you get the general idea. New parent function. Anybody remember what this one is called?
No.
5.
Oh my.
This is the rational parent function. So on the rational parent function, the easiest way to graph the transformations on these, when you're doing any translations that shifts right and left or shifts up and down, it's the asymptotes. Move them, because and I know they're imaginary boundary lines, but if you'll move the asymptotes, it makes it easier to graph. And then this dot right here and right here, they are one diagonal away from the origin of your asymptotes, from the intersection where your two asymptotes meet, unless there's a stretch. So if there's no stretch, which there's not on ours, then once we put our asymptotes in place, then we can identify where those two are supposed to pass through, and the rest of it's just a sketch. for right now. We'll get more technical on that stuff later. Okay, so I do have a negative in front of the entire rational, so that's going to be a reflection. So that's a reflection across the x-axis. And then that -3 is down in the basement with x. So since it lives in the basement with x, that means that's a horizontal change. And x is a liar, so that would be right 3 and up 5. So I'm going to shift my asymptotes right 3 and up 5. Right now, my two asymptotes are at 0, 0, 0, and 0, so I'm going to shift those over. So 1, 2, 3. So I have an asymptote there, and I have, that's my vertical asymptote. All right, so this is now my new asymptote intersection, my new origin. It's also a reflection, so instead of having one in the top right corner and the bottom left corner, I'm going to have one in the top left and bottom right because of this reflection. So it will look like this. Oh, that's terrible. That's a bad graph. Don't do better than that.
I did the same.
That's really bad. But it looks roughly like that. Really, that's really rough, but it looks sort of like that. Number 6. Do y'all remember? Y'all know what this one's called, right? Cubit. All right, take a second and see how you do graphing the cubic one. Let me give you two, before you actually graph it, let me give you the data points that matter. The origin is important. These two, 1, 1 and -1, -1. And then 2, 8. And -2, -8. Those are the, if you know those 5 points, then it makes this a little easier to transform.
No.
All right, I'm going to walk y'all through graphing this one just because it has a compression and we haven't done one yet. So, number 1, the first thing, that 0.5, it's compressed. It's half as tall as it should be. It's shifted left 2 and up 4. So I moved my origin dot left 2 and up 4. Now from there, this next dot over is normally up 1 over 1, but now because I'm compressing my vertical value by half, it's going to be up a half over 1. So it would be like right here and right there. And then the 2, 8 value, it would have been up 8, but I'm compressing that by half, so I'm going to go up 4, 1, 2, 3, 4, and over 2. And down 4 and over 2. So okay. Y'all all right? Anybody remember what this parent function is, number 7? It is logarithmic. It's which, somebody said it. It's natural log, yeah. It's logarithmic, it's natural log, which means it's log base e. This is the original. This one only has two transformations. It's reflected.
And it's left 6.
And left 6. So again, logarithms have an asymptote. It's usually a vertical asymptote at 0. We're going to shift that asymptote 6 over. 1, 2, 3, 4, 5, 6. So I have an asymptote here. And it's upside down. So, and it should pass through, normally it passes through the ordered pair 1, 0. Still going to, it's just going to be over here, and it's upside down, so it's going to look like that. That's, again, that was terrible. I'm not very good at graphing. Like that. All right. So last one, we just learned this one. This is the greatest integer function. I got two transformations happening.
Why is it called greatest integer? If it's truncated.
That's a really good question. It's because it rounds down to the greatest
Integer. it
integer that is in the original. I don't know. I really don't know why they call it that. I actually didn't learn it as the greatest integer function. I learned it as the floor function, and that makes sense because it drops down. So, but I don't know why it's called that. Okay, it's got two transformations. The first one is a vertical stretch by 2. Now, before we actually graph this, what is that going to do to the? Tell me what is that going to do to the looks of the graph? What do you think is going to happen to this?
The lines will be longer.
It's a vertical stretch by 2.
Oh, the lines will be more spread out.
Yeah, they're going to be more spread out. Everything's going to be just more spread out. There's more space in between. Right now, there's one space in between each set of lines. Now there will be 2. So, and then I also have an up 3. So that means that this original dot that's at 0, 0 is going to be up 3. 1, 2, 3. And it will be still stretched like it is. The next one that's here, it would be multiplied first by 2. So right now it's at 1. That would move it to 2, and then from there it's going to go up 3. 1, 2, 3. So it would be right here. These are open, not the same. So this dot right here that's at 2, first you multiply that by 2, which would put it at 4. And then from there you go up 3, so that would put it right here. Once you get the pattern, you can just draw as much of it as you want to draw.
So then?
Yeah. Okay, is everybody good with these transformations?
Yep.
Easy, 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 right? Okay, oops, sorry. Let me get you the page. Okay, so this time you're going to be looking at the function and you're going to be telling me what's happening. So it might benefit you to write down the transformations so that you know how much has to show up in the function. So let me get it to you real quick now. We'll talk through this first one together, and then you can do this. Y'all, don't tell last year's group, y'all are so much better off than last year's group, because they didn't know any other parent.
Not 2, not 4. You start. That's your deal.
I would say, what is this? And they're like, I don't know, I've never seen that before. Oh.
Right? And then it turns out
Okay.
one more.
So if we look at this one, first of all, what is this first function? Yeah, that's a quadratic function. So the most obvious transformation is that it's reflected. It's upside down. So I know it's reflected. What else has happened to it?
It's moved to the right,
Right.
and it's been moved up.
And it is also stretched by 2. So that means I actually have 4 different things that are happening here. A reflected is going to show up in my equation how?
Negative.
As a negative in front of the whole thing, right?
Yes.
The right movement is going to show up as a negative minus something, minus with my x in parentheses. The up is going to show as a plus after the parentheses are closed. And then what is this stretch by 2? How's that going to show up?
Now show up as a 2 right before the equation.
2 right before the equation, after the negative. So it'll be negative 2, parentheses, and then the rest of it. So that means I'm going to have, let's see, a reflection, stretch by 2. Then here comes my x. Now how far right did I go?
7.
Thank you. So it's minus 7, because it went right. Remember, x is a liar, so
3.
squared to show that we know what our parent function is. It's quadratic. Up 5. Everybody good? Everybody feel confident that they can do the rest of these on their own? Sweet. Go.